In this section, we're going to discuss multiplication of matrices. And so there are two things you can do with multiplying and matrices. One is a scalar multiple, or scalar multiplication, and we talked about that in a previous video, and that's when you multiply each element within a matrix by a constant, or a scalar multiple. In this section, we're going to talk about actually multiplying two matrices together. The first thing that you need to realize is that you can only multiply two matrices together if the inner dimensions are the same. So that means the number of columns in the first matrix is the same as the number of rows in the second matrix. To me, that's kind of confusing. I just like to think of the inner dimensions being the same. So for example, if I have matrix A that's a 2 by 3 and matrix B that's a 3 by 4, and I want to multiply A times B, I can see that these inner dimensions, the 3's, match. That means it is possible for me to multiply A times B. Okay? The resulting matrix is going to have dimensions of the leftover pieces. So 2 rows and 4 columns, meaning a 2 by 4 matrix, will be the dimensions of our resulting matrix or our product. If we have those same matrices A and B, can we multiply B times A? So in normal, let's say integer operations, if we wanted to multiply 1 times 2, we know that that is the same as 2 times 1. So multiplication is commutative. We can change the order and it's still the same. Is that the same case in multiplication of matrices? If I want to multiply B times A, and I know that B is a 3 by 4 matrix and A is a 2 by 3 matrix, notice that 4 and 2 do not match. That means we cannot multiply B times A. So the order matters when you're talking about matrix multiplication. You have to make sure that you multiply in the order stated. Now let's see how to actually do this. So, before I do this example, I did get some of the information contained within the video from OpenStack's College Algebra textbook. It's a free online resource, so you can use that link or type in the web address there so you can check out that resource. Okay, so let's look at our problems here. We have matrix A and then matrix B defined as follows. Number 1, is it possible to find the product of A times B? If so, find it. So let's look at the dimensions. A has 2 rows and 3 columns, so it's a 2 by 3 matrix. B has 3 rows and 2 columns, so it's a 3 by 2 matrix. So is it possible to multiply A times B? So A is 2 by 3, B is 3 by 2. The 2 inner dimensions match, so yes, it is possible. Notice that my solution or my product will have the dimensions 2 by 2. So it will have 2 rows and 2 columns. What you want to do here is you want to actually think about distributing each row from the first matrix to each column of the second matrix. So in other words, you're going to take the first row, 1, 3, and -9, and you're going to multiply that by the first column. So the first row times the first column. And it's multiplication of the following. So it's 1 times 11 plus 3 times 3 plus -9 times -5. I'm going to write this out long, okay? So the first element in our new matrix is going to be found by doing what's in the red box. So 1 times 11 plus the product of the blues, so 3 times 3. Those are the second elements, right? It's the second element in the first matrix row and the second element in the first column of the second matrix. Okay, plus what's in green, so the product of -9 times -5. Okay, so each of those first numbers, 1, 3, -9, you can see come from the first row of the first matrix. And each of the second numbers, 11, 3, -5, come from the first column of the second matrix. And so you just multiply and add those together. And that is going to give you your first element. Okay, so now we're going to do the same thing. Okay, except now what we're going to do is we're going to use the second row and the first column. So row 2, column 1. That's going to go right where it sounds like it should go. Row 2, row 2, column 1 goes in row 2, column 1. Okay, so that's what you're multiplying and adding. So again, I can multiply the first elements together and add that to the product of the second elements and add that to the product of the third elements. Okay, so let's see, I'll have 5 times 11 plus -2 times 3 plus 1 times -5. Okay? Now what I want to do, I've taken each of the rows and multiplied it by the first column. So now I want to go down the second column. Okay, so I'm going to start over and do the first row times the second column now. So let's see, the first row times the second column. So notice that's row 1, column 2. So if I go to row 1 and column 2 in my new matrix, that's where I'm going to put it. So whatever row and column you're multiplying, that's where the element is going to go. Okay? So let's look and see what we have. We have 1 times 2 plus 3 times 1 plus -9 plus -3. So 1 times 2 plus 3 times 1 plus -9 times -3. And I'm going to erase some of the stuff I had from earlier because it's just getting in the way. There we go. Okay. And now I need to have my second row and my second column. So that's what I'm going to work on next. Okay, so second row, second column. So that is going to go row 2, column 2. That's going to be where the element is. So we have 5 times 2 plus -2 times 1 plus 1 times -3. Okay, so now you can see hopefully that we have 4 elements. Let me kind of, once you actually do the multiplication and the addition of the red, blue, and green parts, you will see that you have 4 elements. So let's see what I get. So this is 11 plus 9 plus 45. And I think that will be 65. And then for the first column, or the second row, first column, we will have 55, and then negative 2 times 3 is negative 6, and 1 times negative 5 is negative 5. So 55 minus 11 is 44. All right, now I'm going to work on the second column. So row 1, column 2, we will have 2 plus 3 plus 27, and that will be 32. And then we have 10 minus 2 minus 3, so that will be 5. And so that is our product. Notice again that we have a 2 by 2 matrix, and that's because that was the outside dimensions, right? That will happen every time. Let's look at the next one. So the next one is it possible to find the product BA? If so, find, oh, it says AB again. It should say BA. I don't want you to find AB again. Find BA. All right, so let's check. So B times A, we have B is a 3 by 2 matrix, and A is a 2 by 3 matrix. So the two inside dimensions match. That means it is possible in this case to match or to multiply B times A. So it's possible to multiply A times B. It's also possible to multiply B times A in this case. But notice that the resulting matrix this time will be a 3 by 3. The resulting matrix in number 1 was a 2 by 2. So you're going to get a completely different matrix and a completely different answer. So even though we can do the product in either direction or either way, right, we won't get the same answer. So it's still not commutative because we will get different answers depending on the order in which we multiply. So let us try to do B times A. So this time, I'm going to rewrite them down here. Let's see, hopefully that will help. So B is 11, 3, negative 5, 2, 1, negative 3, times A is 1, 3, negative 9, 5, negative 2, 1. Okay, so what we're going to do is think about multiplying each row of the first times each column of the second. So each row of the first times each row of the second. And so if I'm going to do that, I will do row 1 times column 1. Okay, so row 1 times column 1. And it shouldn't be a surprise that that gives you element A, 1, 1, because it's row 1, column 1. This next one is going to be row 2, column 1, row 3, column 1. Now I'm going to find here, this is row 1, column 2, row 2, column 2, row 3, column 2. And then here I'm going to have row 1, column 3, row 1 times column, whoops, that's row 2 times column 3, and then row 3 times column 3. So that's how I'm finding the elements of that matrix. So again, I'm multiplying each row times each column. So if I do that, let's see what I will get. So I will get 11 times 1 plus 2 times 5. And if I want to go ahead and simplify that now before I move on, I can. So that would be 11 plus 10, which is 21. All right, now I want to do, see if I can just erase the red. Nope. Nope. All right. I'm going to have to fix that. Okay, so I fixed that error. I accidentally erased some of that matrix. So now what we want to do is we want to multiply row 2 times column 1. So now we want to do row 2 times column 1. And so that will be 3 times 1 plus 1 times 5. And if we want to go ahead and find that element, that will be 3 plus 5, which is just 8. Okay, now I want to find the product of, row 3, column 1. So that is going to be negative 5 times 1 plus negative 3 times 5. And so that'll be negative 5 plus a negative 15, so that will give me a negative 20. All right, so now I've completely finished multiplying each row with column 1. And so now I'm going to multiply each row times column 2. So I'm going to take row 1 and column 2. So row 1, column 2. So when we do row 1 times column 2, we will get, I'm going to put a little dotted line here just to separate the columns so that we don't get confused. So we have 11 times 3 plus 2 times negative 2. So 11 times 3 is 33, minus 4 would be 29. Now we want to find row 2 times column 2. And so row 2 times column 2 will have 3 times 3 plus 1 times negative 2. So it'll be 9 minus 2, that's 7. Now I want to find row 3 times column 2. So that will give me negative 5 times 3 plus negative 3 times negative 2. So that'll be negative 15 plus 6, so that will be negative 9. Okay, we've now multiplied each row from the first matrix times the second column in the second matrix. So now it's time to multiply each row by the third column. Okay, so first I'm going to do the first row times the third column. And so that's going to give me 11 times negative 9 plus 2 times 1. So that'll be negative 99 plus 2, so that's negative 97. Okay, now I want to find row 2 times column 3. And so that's going to give me 3 times negative 9 plus 1 times 1. So that will be negative 27 plus 1, so that'll be negative 26. And then finally, I want to do row 3 times column 3. And so that will give me negative 5 times negative 9 plus negative 3 times 1. So that will be negative 45 plus a negative 3, so that'll be negative 48. And so that 3 by 3 matrix will be our product when we multiply B times A.